is an abnormal molar mass? You see, ionic compounds. What are ionic compounds? Ionic compounds which are having a cation present in it. Cation is what? It is positively charged. Cation is positively charged, and we are having an anion also present in ion which is negatively charged. Okay, so cation and anion together they form ionic compound. Okay, so ionic compound on dissociation. Dissociation means breakage of bond. It increases the number of moles in solution. Okay, so what will happen? The experiment value of the molar mass, it gets lower than its true value. Okay, the experiment value of the molar mass, it gets lower than its true value, which is termed as abnormal mass. Okay, let's take an example here for KCl. Here it is written here, KCl. KCl is getting what? KCl is an example of ionic compound having K is having positive charge here, all right, and Cl is having negative charge. So this is an example of ionic compound, right? So what kind of reaction they are showing? Dissociation reaction, where potassium chloride is dissociating into 1 mole of potassium and 1 mole of chlorine, right? So if we calculate their molar mass, the molar mass of the experiment value, it will be lower than its true value. Okay, if we can check here, the molar mass of KCl here, it is given as 1 mole. But if we calculate the molar mass of potassium and chlorine separately, okay, this will be the lower than its true value. All right, so 1 mole of KCl, it will produce 2 moles of respective ions. Here we are having 1 mole of KCl and here we are having 2 moles. Okay. Let's take, this was an example for dissociation. Let's take an example of association for acetic acid, where acetic acid, the molecules of acetic acid, they are forming a dimer, or say they are getting associated. All right. So here the moles of acetic acid, or say ethanoic acid, as I said, they dimerize, they get associated in benzene due to hydrogen bonding in there. Okay, so in such cases, the association takes place. All right, how we calculate this abnormal mass? By want-Hoff factor. Okay, which is very important. Want-Hoff factor is given by Want-Hoff scientist. It is denoted by small I. Okay, it is used to determine, or say to evaluate, the extent of association and dissociation in a molecule. Okay, like at what extent the dissociation and association takes place in a molecule. So for this we are having formula for Want-Hoff factor, that is their normal molar mass plus the abnormal molar mass. What is abnormal molar mass? Its value will always be less than its true value. Okay, we can also term Want-Hoff factor as observed colligative property and experimental colligative property, or we can write it as total number of moles after association, or say total number of moles after dissociation, divided by number of moles before association and dissociation. All right. And we can also relate Want-Hoff factor with all the colligative properties. Here we are having colligative property, the first colligative property, second colligative property, third and fourth. How are we relating the Want-Hoff factor? Here, to all the colligative properties, right? We have just discussed the 4 colligative properties. Okay, why we are relating the colligative properties? with the van 't Hoff factor to check at what extent the dissociation or association has been taken place in a molecule, to what extent the difference in their molar mass is coming. All right, so let's do an example relating to the van 't Hoff factor. Right. This is an example where we will be using the van 't Hoff factor. How to use this in numerical. So if you can read an example, the given example, an osmotic pressure of 6.3 atm is exerted on 0.5 molar aqueous solution of KCl. KCl will be doing what? It will be showing dissociation, right? At a temperature of 310 Kelvin, you have to calculate the degree of dissociation of KCl molecule. For that, value of R, that is gas constant, is given. Which formula we are going to use with this? The osmotic pressure, right? Which formula that we have discussed in the fourth colligative property? Pi is equal to CRT, and we have to add here van 't Hoff factor also. Pi is equal to ICRT. Right. First, we have to calculate what? This degree of dissociation. We have to calculate what? This I value. We can calculate or no? I will become equals to pi over CRT. Right. We know the value of C. We know the value R, the value is given. Temperature value is given 310. All right. So we can easily calculate the degree of dissociation here. All right. Right. That's it in solutions chapter. We will do a quick summary and then I will take the question and answer query regarding this chapter 1, solutions of chemistry. Okay, if you're having any doubt, feel free to ask me in poll or in question and answer space. So let us quick review what we have done today. We have done the very important topic, colligative properties, right? Before starting colligative properties, what we discussed the Raoult's law that we have discussed in our first class, that vapor pressure we have discussed that colligative properties are of this 4 types, where we have discussed relative lowering in vapor pressure, that the vapor pressure, it will decrease gradually as we are adding non-volatile solute particles to the solvent. We have discussed in depression of the freezing point in solvent that the freezing point, it will gradually decrease as the vapor pressure will decrease. Okay. We have discussed that the boiling point of solvent, it increase. Why? Why there is elevation of boiling point in the solvent? Because the solvent particles, they are having full access to the surface of the molecules and they can evaporate more easily than the solvent having solute particles in it, right? We have just discussed the osmotic pressure. What is the osmotic pressure? The pressure we apply to stop the process of osmosis. What is osmosis? Yes? Can anyone tell? Osmosis is what? Where the solvent particles, they are moving through the semi-permeable membrane, okay, to lower concentration, from the lower concentration region to the higher, from the higher concentration region to the lower concentration region, right? This is for relative lowering vapor pressure, okay. The derivation of Raoult's law for relative lowering of vapor pressure, that is for First colligative property, this is very important and it is very much asked in the exam. Okay, we have discussed the numerical problems. I think we can easily solve the numerical problems related to first colligative property, right? Then we have discussed the second colligative property, elevation in boiling point, that how the elevation in boiling point takes place. We have studied with, we have understood with the beautiful graph here, right? Which is showing the curve for solvent and solution as well. All right. We have done the derivation of boiling point. For boiling point and freezing point, the derivation, the formula derivation is quite similar, right? For freezing point, can anyone tell what is freezing point? Yes, where the vapor pressure of solid and vapor pressure of liquid, they become equal, right? And we observed here decrease in freezing point and a point where the, say, freezing point of solvent and freezing point of solution, they meet at one point, right? We have derived formula for to calculate depression in freezing point, same as we derived for elevation in boiling point, right? And we have discussed one important point there, that Kf and Kb value, what are these? Constant for freezing point, say gyroscopic constant. This is ebullioscopic constant for boiling point constant, right? That their value, they are independent. We have discussed they are independent of number of solute. Okay, they depend, or say they depend on the nature of solvent, on nature of solute only. Okay, their values vary depending on the nature of solute particles, gyroscopic and ebullioscopic constant values. All right, next we studied about the osmotic pressure. What is osmosis? Read that again. Where the solvent particles, they move to lower concentration. Don't get confused in this. They move to the, from a lower concentration to the higher concentration. Okay, like this, like if we take a solute salt solution will be having lower concentration, right? And other side we are taking water, so the particles will move from the lower concentration to higher concentration, okay, until an equilibrium is achieved. Osmotic pressure we studied, it is represented by pi. Formula is equals to CRT, where C is molarity, T is temperature, R is gas constant. Value will be given in the numericals in exam. All right. And again, we derived a formula as we derived for other colligative properties. And pi is equals to N2 RT by V. Okay, where we have here in place of C, we put the value for molarity. What is molarity? Number of moles of solute particles. Okay, number of moles of solute particles present in solution divided by volume of solution, right? That is N by V. Solute we are using 2. That is N2 by V. Now you understood this, where this came from. And then for N, what is N? N is what? That is mass, that is W, by molar mass, that is capital M. Understood? W2 by M2. I hope this formula is clear to you now. And we have discussed these three effects of osmotic pressure, right? Isotonic, hypotonic, and hypertonic. Very often they are asked in exam, right? Then we discuss the reverse osmosis process, and where the reverse osmosis process is used. It is used in purifying water. It is the pressure applied to the solution higher than the osmotic pressure. Okay, and then the direction of osmosis, it get reversed. Direction of osmosis, it get reversed. All right. And the last topic we discussed, that is abnormal molar mass, right? Where we discussed what is abnormal molar mass, where the value, or say the experimental value of molar mass is what? Molecular mass. Okay, it is coming lower than its true value, that is abnormal molar mass. All right, as we can see here, there it can be divided into two types, association and dissociation. Okay, why this value varies? Why the molar mass comes as abnormal mass? Because in reaction, association and dissociation of molecules takes place, right? As we can and association and dissociation, this generally happen in ionic compounds only. Okay, either they get associate or dissociate. So we have taken a dissociation example here and an association example here of acetic acid, where a dimer has been formed in benzene, and to that we understood that the abnormal mass, right? And this can be determined by the von Hoff factor, this association and dissociation change. Okay, the change taking place in the molar mass by association and dissociation. It can be calculated by using I factor or say von Hoff factor. Okay, and this can be used in all the colligative property, this von Hoff factor I. This is relative lowering of vapor pressure colligative property. This is elevation in boiling point. See here we are using von Hoff factor to check the difference in molar mass, right? This is for freezing point and osmotic, right? So in next class, we will study the electrochemical cell, the chapter 2. So let me see if you are having any queries till now. Right. Please study and ask questions if you have any. In chapter 1, we have finished our chapter 1. I hope you have understood all the topics. Right. So you can tell me if you're having any questions. So let me tell you again that, just a second. You can ask me any question if you're having any doubt. We are available to clear your Right. Sorry, we might have technical issue. So we are working from a groundbreaking platform, that we are having a groundbreaking initiative from our platform, go to university.com. All right. So this is requested to all of you to take the advantage of this opportunity, right, to elevate your learning experience and to excel in your academic journey and to share more with your fellows. All right, because here we are providing access to mock test paper per subject and to the past 5-year papers, right, to prepare for your exam, okay, to do more comprehensive study. And you can also do the self-evaluation in mock test paper and past papers. You can have access to the study material and by topic and subtopic. Okay, so all is there. You can also have access to 10,000 practice question. You know, each for each chapter we are having more than 200 practice questions. Okay, whether they are MCQ, assertion reasoning questions, subjective questions, very short, and case studies as well. All right, so take the advantage from this, okay, and elevate your learning experience and excel in academic journey. Okay, so I'm here to take any queries if you are having any regarding the chapter 1. We will study chapter 2 in our next class. Right. Right, osmotic pressure. Let us see again the definition for osmotic pressure. 1 second. Oh, you want to see the exam tips? Just a second. Right, I'm sharing exam tips. All right, so I have shared here tips for exam for you to study, which is there for each subtopic. Okay, this is for solutions. as we discussed, that solution is what? It is made from solute and solvent. You can also term it as binary solution, where solvent is present in larger quantity and solute, that is solid part, it can also be solvent. It is present in least quantity. Okay, and solvents, they can be identified as present in larger quantity, and solute, it can be having more than one substance also, right? For binary solution, here I have given an example, that is 1 plus 1. 1 plus 1 means one solvent and one solute. Okay, and this chapter, the whole chapter is all about binary solutions, right? Right. Let us move to other tips for exam. If there, just a second. Right, let's see with types of solution. There is tips for exam, for concentration of solution, for each and every subtopic. Okay, so you can have thorough reading here. You can prepare well for exam, right? Just a second, it is taking time to load. Let me check one second. Yes. And you can have free access to all this material, these slides. All right. See, tips for exam, for expressing concentration. I think this is very important to solve the numericals in exam, right? You can have free access to all the study materials here and to the mock test and past papers, right? See. Plus, related videos are also there so that you can understand the concept. So this whole site is designed by Go to University, right? See, at equilibrium, the more volatile a substance, the greater is its vapor pressure. What is volatile substance? Volatile substance is what? That has no solute in it, that is only solvent, and that is having more evaporation, or say high vapor pressure. All right. If you can read this, for ideal solution, an ideal solution is very rare. Okay. It is exhibited by solutions of N-hexane and N-heptane, benzene and toluene, bromoethane, chloroethane. Okay. These are some quick tips that you can revise. This is very important for azeotrophs, that they cannot be separated by frictional distillation. Right? What was azeotrophs? You can check here. Okay. Two types of azeotrophs were there, which show minimum boiling point, and that one which show high boiling point. With the minimum boiling point, they show positive deviation as we discussed in yesterday's class. And for higher boiling point, azeotrophs, they show large deviation. Okay. So what are azeotrophs? They are the mixtures. Okay. See, alloys. Can be mixture of anything, metal, metal, non-metal, metal. Okay. Colligative property, we just discussed. Solubility, types of solution, expressing concentration. I hope this chapter is very much clear to you. Okay, this chapter is easy, right? Although the numericals regarding to the concentration, they are challenging in exam as well as in practice question. But I think as we have studied it well now, we can solve the problems easily, right? We did an assertion reasoning question relating to this, the examples that we solved, right? Right. I want you to practice this assertion reasoning question again that we discussed yesterday. Right. What was the answer for this? A. Very good. Right. So let's summarize this chapter. You can see here summary for solutions chapter. Please read it and tell me if you have understood all these points or not. Have a look at it. The first point, solutions, we have done homogeneous mixture, heterogeneous mixture, in solid, liquid and gaseous forms, their concentration, how to express concentration, mole fraction, molarity, molality, volume percentages, mass percentages, right? Henry's laws we have discussed for the solubility of gas in the liquid. What example we relate to this? The example of Coke, right? Right? High pressure, high will be solubility of gas in liquid. Okay. Remember Henry's law? Right. And then we discussed Rod's law, that is for vapor pressure. On that we discussed we also discussed volatile and non-volatile solutions. We discussed ideal and non-ideal solutions. We discussed their positive and negative deviations, which result in azeotrophs, right? Then we discussed today colligative properties, 4 types of colligative properties: relative lowering in vapor pressure, freezing point, osmotic pressure, right? We have discussed osmosis, reverse osmosis, and colligative properties in determining abnormal molar masses, how we can use Van Hoff factor. In numericals, what is Van Hoff factor? Degree of dissociation associations, right? So I hope this chapter 1 is clear, very well clear to you. So I wish you well for the preparation of exam. Okay.